Hi, I'm Joel May with BASF. I want to talk to you a little bit about resilient construction and disaster durable solutions. What are disaster durable solutions? Well, we are solutions that make the built environment more resilient to climate change, man-made or natural disasters. And we do that by offering help with project delivery, life cycle of performance, sustainability, affordability, and finally, well-being of the occupants inside that building. One of the things that we face is severe weather, and we know that severe weather will exploit failure points on a building. As we can see here, wind load rips off that roof, then storm surge comes in and washes it all away. We know when we lose a roof deck alone that more than half of the rest of the building components will be exposed to wind-driven rain, water intrusion, and all kinds of other things, which will leave your building at risk of secondary damage. We also know that you'll lose the use of that building. Whether it's your home or your business, it could be up to 6 months to 6 years before you can reoccupy. And then we also know that the cost to rebuild can be up to 10 times more than just building something new again. And finally, the second disaster you face is trying to find a contractor to put you whole again. And we all know how difficult that can be. Well, we have a solution, and it starts with the camera not lying. Digital technology allows us to better inspect, help predict outcomes, as well as redefine what happens before or even after a disaster. In this case, using a drone to inspect a building not only is faster, safer, and really smarter, it allows us to see what the naked eye couldn't. In this infrared view, we find that we have a bird bath which is causing interior leaks and damage post-Harvey that interrupted business in this particular factory for up to 6 months and cost them millions of dollars in production. We have been using infrared cameras for years. We've been doing blower door testing to try to find out where is our comfort energy coming in and out of the building. We can pretty much pinpoint that. But did you know you can also pinpoint where you'll have failures in a deck, be it in a residential structure like you see here, or a commercial building. Infrared can allow you to see where a failure will occur before it does, so you don't wind up with your roof deck being lost. Now, we have an example where we built a home, and this was in Breezy Point post-Sandy, and we did that with a group called the Federal Alliance for Safe Home and their partners. And this was called the Hurricane Strong Home. It's a great story. Go to the website and you can take a look and learn more about it. But let's go through the process. It was all about teamwork. Teamwork makes the dream work. When we have the right people, the right processes, and we choose the right products, we always have a great result. When we want to choose good products, we want to make sure they comply with local and even federal requirements. In this particular case, we used flood-resistant materials throughout the building. Our BASF spray-tight closed-cell foam is noted in the FEMA fact sheet number 8 to be the only insulation you can use in a flood-prone area that can withstand up to 72 hours of floodwater and then be easily dried, cleaned, or serviced. So it's very important that you're following these guidelines as well as checking with your local code. And we have those technical documents at BASF to help you if you're walking it through plan review or you're looking to get insurance. Next, the best processes. When you're thinking about designing a hurricane-proof structure, one would want to refer to the Insurance Institute for Business Home Safety's Fortified program. And why we like that is because the Fortified program allows us to have deeper insights to how a building goes together. So it knows that if you have a roof line that's not attached to your wall, then your wall to the foundation, you're going to have a big problem. So the design tips and tools used in the Fortified program are what we chose. And I'm also a Fortified rater, so I'm able to understand how these components work, inspect the process, verify that those materials showed up and that they were installed properly. And through the magic of time-lapse photography, we can show how we built the foundation, put in the insulated concrete floor, then the walls, and the roof decking. And throughout this process, we were able to learn a lot more about how the building worked itself, how the workers performed, and the engineers, the inspectors, everyone had a live feed of this, so they were able to tell when something was done, how it was done, and if it was done properly. So, through the magic, we are done. And there it is. Every step of the process was very well documented. In this particular case, we used body cameras and personal cell phone cameras. This allowed us to speed up the inspection process, verify that the footings were the proper depth, that the rod in this particular case was done, as you can see, coming up through the insulated concrete form floor, all the way up to the walls and end walls. I was able to verify the load path as it relates to how the roof sat on this project with the Simpson strong ties, the packaging, each of the numbers, all of the straps, and the fasteners were all verified by me, the Fortified Rater. This particular case, I took a lot of photos. I had our carpenters take the photos, so I have a complete catalog of every screw, nail, strap, as well as the delivery sheet, knowing that these products got there, when they got there, and when they were applied. So I know they're the right thing. Then our work order details. As we saw in the video, we had to make sure that our workers knew what they were doing. So we wrote a very good work order. We sent it out via email that showed the exact detail from the flashings to the underlayment, so there wasn't a mistake. And this was a good practice to follow, and it is now sitting in the permanent file. The product verification, everything that went into this building all had certificates of compliance for extreme testing. In this particular case, our BASF spray-tight close-cell foam had been tested to go beyond the requirements for Dade County in the uplift, which you can see here on this form. We actually perform about 3.5 times stronger than the requirement for hurricane uplift. So we know that this roof is very strong. And it is very important that all your manufactured products have this documentation, where you can find all of ours at our BASF website. In this particular case, it would be the spray foam site. So by having this verification, we were able to give that over to the insurance company, to the building official, as well as the government program overseeing this particular product. And we verified also all the packaging and labels on the windows, as well as the windows once they were installed. I personally went through, I looked at every package when it arrived, I checked off the list. I then looked at every sticker for the Class D missile, which is your impact rated missile, as well as the Energy Star rating you can see over here, verifying that each of these windows met the minimum federal requirements for energy. Because not only were we going for resilience, we wanted to make this building more energy efficient. One of the key benefits, when I can't be there to verify that the process was done, we had our spray foam applicators use their cell phones and work behind one another to verify that the spray pattern was done properly, so that we at least had that minimum of 3 inches with spray tight, which gave us that 3.5 times stronger uplift, as well as being a secondary water barrier. So this is very important here to verify the performance. Now, all this information eventually wound up on the cloud. As we were doing this real time. So our code officials, our engineers involved, the contractors, even our manufacturers were using this cloud to exchange data and to give us minute by minute, day by day updates as to where our project sat and how it performed. As you can see, we have a lot of thermal images here, and I was able to get thermal cameras out on the job site so we can look at performance verification during the rough stages, which is very important. I know that building doesn't have leaks. And when it was all said and done, we initially had an air exchange of 0.22 per hour when this building was finally verified. And I know that's been adjusted a few times for the doors and windows, but what an amazing, strong, tight building. And I can confidently say that because not only did I verify it, we used the digital technology to do the same. And we created this really neat artificial intelligence program that kind of puts everything together in perspective, taking all of our information, actual job site footage, matching it up to a computer model So not only can you see where we performed well, you can also put it together in a score, if you will, and you can actually see through this thermal imaging where there may be an issue while you're building, and in this particular case you can make that correction before the drywall goes up. So we did pretty well on this one, and we used a lot of great technology to verify it. The future of construction is going to have a lot of virtual reality. We put together a simulation doing that very thing. So we were able to show how the building works in different environments, be it a rainstorm like this, or a flood event like this. More importantly, we can get inside and really go behind the walls and see what's happening. And what's exciting about this is that you could put on your goggles, walk through the simulation as if you're there, look around, and certain things will point to the performance, the straps that were built, the flood vents below, all to let anyone in our future that is familiar with using gaming be able to be an inspector, perhaps even a designer, to where you'll be able to experience the whole building process from your own living room. So by capturing this and using these tools, Disaster Durable Solutions is not only leading the way for the built environment, we are actually taking us to that next level so that those that want to enter this workforce can use their skills and talents that they've acquired and really make a difference in design, performance, and verification. Because really that's where our future is. And we do a lot of wasteful things today. If we can just eliminate those steps and those processes for our customers, for our community, and for those end users, we all save in the long run. And that's what Disaster Durable Solutions is all about. So digital technology today allows us open source views of building permits, history of a building, flood statistics. This is me right after Irma doing my own evaluation of weather damage. This photo has gotten over 500,000 hits, and it's going to be there as long as the internet exists. The point is, if we're not staying current, verifying that we're using the right products, the right processes, people are going to know about this. They know there's inherent risks where they buy, where they live, where they work. And these are going to cost us more if we don't take measures to be resilient. And that's why BASF materials are changing to adapt to these challenges. We overcome them by supporting our customers, the projects, communities being built, all the way down to the end user occupant of that particular building. And that's why we're delivering disaster durable solutions. Thank you for your time, and I look forward to helping you on your next project.